Hello everyone, and welcome to the launch webinar of a new guidance document on flaring management for the oil and gas industry. This is a joint guidance by Ipieca, IOGP and the World Bank GGFR partnership. My name is Jim Herbertson, Technical Director for Climate and Energy at Ipieca. I'll say a few words of introduction, as will IOGP and the GGFR, before we move on to the main speakers. But first, while people are assembling, I'll just walk you through some housekeeping items. So the webinar is being streamed through your computer and there's no dial-in number. Everything you see on the screen, including the slides, is resizable and movable. So feel free to move things around and get the most out of your screen. At the bottom of the screen, you will see some features that are available. You can use the Q&A box to ask questions as we go, and the speaker biographies can be accessed on the side of the screen, and the slides are available in the resource list if you would like to download them. Also, there is a help feature, but most issues can be sorted by refreshing the page using the F5 key. And this is particularly useful if you think your slides are falling behind. A recording will be made available later this week and can be accessed using the same link that you are using now. With regards to Ipieca, we are not an advocacy organisation. We concentrate on technical and fact-based information to advance the environmental and social performance of the oil and gas sector and its contribution to the energy transition in the context of sustainable development. 29 of our member companies now have net zero commitments by 2050, which is more than half of our membership. These cover Scope 1 and 2 operational emissions, and 9 of our members also include Scope 3 emissions in their net zero by 2050 aims. But we need also to consider opportunities in the near term. Paragraph 17 of the Glasgow Climate Pact, the declaration from COP26 last November, recognises that limiting global warming to 1.5 degrees requires rapid, deep and sustained reductions in global greenhouse gas emissions, including reducing global CO2 carbon dioxide emissions by 45% by 2030 relative to the 2010 level. And to reduce the footprint of oil and gas operations and minimise Scope 1 and 2 emissions, especially in the near term to 2030, then two opportunities really stand out. One is methane reduction, and the other is reducing flaring, which is why this joint guidance on flaring is so timely, and which is why Ipieca is a supporting organisation to the GGFR Zero Routine Flaring Initiative. I'd also like to take the opportunity to thank several people for their energy and their enthusiasm along the way. Harshit Agrawal of the GGFR partnership, Soraya Poche, who was at IOGP, and Moruf Aminu of Ovintiv, who chaired the joint task force that put this guidance document together. Their contributions, as well as that of Carl Werdak of ERM, who you'll hear from later, were essential to the whole project. So without further ado, I'd like to hand over to Harvey Johnston of IOGP for a few brief introductory words about IOGP, followed by Zubin Bamji of the GGFR partnership. Over to you, Harvey.
Thank you, Jim. Well, hello everyone, and welcome to this Flaring Management Guideline webinar. My name's Harvey Johnston, and I'm the Environment Director at IOGP. Now, for those who don't know IOGP, we're a member-driven, not-for-profit organisation which has been serving the upstream industry for more than 45 years. We serve as a unique forum, and we share know-how and good practices in the areas of safety, health, environment, and climate. We work with over 1,900 experts from our member organisations in 13 different committees and over 80 subgroups, which is all aimed at driving good practice in the upstream industry. In 2021, we undertook a strategic review which identified a need for a cultural shift across all of the activities within the oil and gas industry, and particularly to consider the low carbon agenda within our routine activities. Now, achieving this cultural shift in energy is going to involve sharing experiences and raising awareness of existing resources and tools so that we can formulate best practices. As a result of that strategic review, IOGP's new Energy Transition Directorate was formed and is addressing the low carbon prioritised opportunities that were framed out of that strategic review. The 4 energy transition topics that we're working on are electrification, and this is one of the main priorities to tackle stationary combustion sources, carbon capture, transport and storage, best available technology in energy efficiency, and finally, minimisation of all flaring and venting activities. So as you can see from those 4 priorities, flaring is a major theme as well as a methane source for many companies. And we're targeting the delivery of a number of recommended practices, lessons learned and guidelines across those topics over the next 2 years. But outside of that specific program, there are other examples of how we're supporting our members and industry in this space. So we have a task force and are working with OGCI and Ipieca on recommended practices for methane emissions detection and quantification, which we hope will be concluded and released by the end of 2022. And that's to enable a better identification of methane emissions from assets and regions, and an increasing ability, obviously, to reduce those emissions. We're also supporting, we're a supporting organisation to the Methane Guiding Principles, and we lead their outreach program aimed at embedding methane reduction across the industry and the gas value chain. And a great example of the work being done by the MGP is the impending launch in May of a free online tool to help users improve quantification of methane from flaring. By asking a series of questions, this tool will lead users to examples of best available technology they could consider to better measure methane from flaring. And it will cover measurement of flows, gas composition, and flare combustion efficiency. Each technology within that is clearly explained with supporting case studies. And the tool will be hosted on the World Bank's Global Gas Flaring Reduction Partnership website. And then finally, obviously, we have the completion of this flaring management guideline in partnership with Ipieca and the GGFR, which is obviously the reason why you're all here today. So in summary, there's a lot of work going on in the methane reduction space by the oil and gas industry, and this flaring management guideline is a central part of that toolkit. So I hope you find the webinar interesting and the document very useful. Thanks for attending, and I will hand over to Zubin.
Well, thank you, Harvey, and thank you, Jim, and thanks to both of your organizations for the excellent collaboration with our team, Harshad Agarwal, Martin Howells, Adam Pollard, and others. I think it's important that industry partner and collaborate as much as possible to achieve what we at the bank believe is the defining development challenge of our time. And that's addressing climate change and doing all we can as an industry to help mitigate the impacts that result from oil and gas production. So this guidance on flare management comes at a critical time for oil producing country governments and national oil companies that we at the World Bank and GGFR work with on a daily basis. Many of these countries need substantial support, advice, and guidance. And this report should help in many ways, while also helping accelerate the decarbonization of oil and gas production and potentially expanding energy access as well, which is one of our primary objectives at the World Bank. So in short, we hope this report will be helpful for all governments and companies in their efforts to achieve zero routine flaring by 2030. It's also our hope this report, in tandem with reports like the Global Regulatory Review that Martin Oswald from our team will be presenting later today, actually in just a few minutes, it's going to significantly help our collective goal to end routine flaring and venting. So look forward to hearing from the speakers today, and thanks again to IOGP and Ipieca for organizing this webinar and for the good collaboration on this report. Thanks very much.
Thank you, Harvey. Thank you, Harvey and Zubin, for those words of introduction. So the slide up here has got the webinar agenda. So we have an excellent lineup. I will let the speakers introduce themselves at the appropriate time. First, we have Carl Werdak of VRM, who will present the outline of the flaring management guidance itself. Following this, we have 2 case studies on flaring reduction, 2 of the case studies that are in the guidance. Thomas Hurlbacher of Vintalaldea will talk about integrating associated gas capture during field development in Argentina. and then Sarah Alcal of Qatargas, who will present a case study on reducing flaring from jetty boil-off gas at an LNG facility in Qatar. And to round out the presentations in the webinar, Martin Oswald of the GGFR Partnership, as Zubin mentioned, will introduce a recent study covering a global review of regulations on flaring and venting and the key lessons that have been learned. And we hope to leave plenty of time for a Q&A at the end. And with that, I will hand over to you, Carl. Go ahead, Carl. The floor is yours.
I think, Carl, you're on mute. Sorry to interrupt.
Thank you very much. Hello, everybody. My name is Carl Werdeck. I'm with ERM. I want to welcome you all to the webinar, and hopefully on your screen you can see a cover photo of the document itself that we're going to be walking through today. I want to acknowledge the significant technical and editorial contributions made by the staff and members of Ipieca-IOGP and the GGFR in pulling this document together. It truly was a labor of love for all of the folks that were involved. Actually, the document builds from prior work done by the World Bank-led GGFR starting in 2002. And in fact, in 2011, there was a document that was published by the same three organizations that offered a detailed stepwise approach to manage flaring. That document is still very relevant and is referred to often in this current document. Well, since the publication of the 2011 guideline, there have been significant new developments in the field of flaring reduction in terms of technology, business models, operational improvements, and regulatory policy. And this new publication builds on the learnings and the momentums of the earlier efforts from petroleum producers, governments worldwide, to help drive further reductions in associated gas flaring. So my agenda today is to walk through, at a high level, the contents of the FMG, as we call it. It's really structured into three sections. The first presents the core concepts, definitions, and a context for flaring and associated gas flaring. A section focused on oil and gas operators, especially the challenges and solution frameworks that can be employed to reduce routine flaring and non-routine flaring. And then finally, and I think this is a new addition to the debate or the conversation around flaring, is we've got a section focused on what governments and regulatory bodies can do and the tools that they can use when helping to shape a flaring program to encourage productive use of associated gas. So my goal today is to hit the high points. The document itself is over 100 pages long, and I'm sure if anyone you have had a chance to glance at it, it's full of information. So my goal today is not to walk through every page, but simply to hit the highlights and hopefully pique your interest to dive deeper into certain sections. So a little bit about context. Associated gas, obviously, is the gas that's flared when produced as a co-product during oil extraction. There's significant volumes of associated gas flared annually at oil production sites around the globe, contributing to climate change by releasing carbon dioxide and methane. Much of this flaring occurs routinely, typically on a continuous basis. It also occurs because events that are non-routine in nature and lead to either an unanticipated interruption of natural gas extraction or oil production, processing, transportation, and downstream handling. Some flaring is also attributable to emergency or safety incidents. Obviously, flaring wastes a valuable energy resource that could be used otherwise to provide energy to support economic growth in many locations around the world and help society make progress towards the UN Sustainable Development Goals. Globally, many companies and countries have successfully reduced flaring from production operations, and this makes good environmental and business sense. But there's still a significant level of routine flaring associated with gas on a global basis, as shown in the figure. Next, I'd like to touch on the fundamentals of gas flaring. So this represents the first part of the guidance document itself. We'll cover monetization of associated gas from the perspective of key participants in the value chain and their respective roles in the decision-making process. The second is to actually walk through the value chain and give some overview of the reasons why flaring occurs, especially along different segments of the value chain. Next, I'd like to cover a little bit about technology and the options that are available. And finally, talk about categorization of associated gas projects, including economic and technical drivers. Well, in a well-functioning market, associated gas would be valued on an energy equivalent basis with other energy sources. Producers would find valuable uses within their own operations, or for-profit companies would provide facilities and services to capture the gas and deliver it to satisfy customer demand. But the fact is, the amount of gas flared has not substantially declined over the past 10 years, and this indicates that markets are not always well functioning. Instead, any number of factors make economic justification of associated gas monetization difficult. And sometimes, in the absence of subsidies, carbon taxes, or government policies, it is a challenge, one that's difficult to overcome. There's a number of participants with influential roles in the decision processes that can determine whether associated gas is monetized rather than flared. We begin with the resource owners. These can be individuals, partnerships, companies, other private parties, governments, and including national oil companies. Many resources are developed with multiple venture partners and various equity and contractual arrangements that cover their relationship. The nature of these arrangements may play a key role in how the resource is developed and how partners view and influence investing in flare minimization. In almost every instance, though, the resource owner desires to realize royalty or other income from the production of the hydrocarbons as quickly as possible. The production operator has challenges when those contractual arrangements between themselves and the resource owner do not incentivize flaring reduction. For example, production quotas and/or oil and capital constraints may limit investments in capture, processing, or conversion, or in the transmission and distribution facilities to create value by utilizing associated gas. In the cases where the production operator is the resource owner, such investment decisions require alignment of several factors, including market demand, gas price, takeaway infrastructure, and many other factors, some of which are outside the scope of the production operator's control. Government authorities also have significant influence over the process. Their actions can affect 4 areas: upstream oil and gas through legislation and regulation, commercial law and contractual practices, a fiscal framework, mainly royalties, taxes, and subsidies, and finally, environmental and safety regulation. Midstream entities are a significant player as well in monetizing natural gas. These midstream entities consist of gathering, processing, transportation facilities and other services that connect upstream wells to downstream customers. In some cases, the parties are separate entities from the upstream production companies and the downstream customers, making for significant contractual obligations that go both ways, up and down the value chain. Historical experience has shown that midstream capacity additions often trail the growth of associated gas production, primarily due to limited competition, large initial investment requirements, and in the case of pipelines, the requirements for landowner access and regulatory approvals. Fluctuating market conditions also sometimes hamper the development and build-out of midstream processing facilities. Processing and pipeline capacity limitations, even if they're temporary, can often lead to flaring in the upstream operations. Finally, there's sellers of natural gas products. Depending on the geography and/or the investor base, entities that market fuels represent an emerging stakeholder group that can have a significant influence on the disposition of associated gas. This arises from customer expectations, industry standards, and possible regulation regarding the carbon footprint of fuels. The schematic on this slide illustrates the flow of gas along the value chain in those operations from the oil and gas wellhead all the way through processing, transportation, liquefaction, or conversion to natural gas fuels, chemicals, or other derivative products, and finally, end use. There are several key attributes to consider when thinking about this value chain. Often, the owner of the hydrocarbon resource is a separate party from the operator that explores for and produces the resource. Due to inherent price differentials between hydrocarbon liquids and gases, even on an energy equivalent basis, the resource owner and the operator can, and sometimes do, place priority on the crude oil produced versus the co-produced associated gas. Intermediaries in the middle section of the value chain add value through processing, upgrading, and moving and distributing the natural gas. But these facilities, the midstream section, tend to be capital intensive, capacity limited, and are fixed in place. Commercial arrangements between parties are often long-lived and involve sophisticated provisions that deal with downstream risk mitigation related to certainty of supply and fluctuations in commodity prices. For all customers, especially for industrial and electric utility plants and exporters, there is no convenient, cost-effective substitutes for natural gas once that contractual arrangement is established. The bottom graphic on the slide attempts to hit the highlights for why flaring can occur. There's many reasons. Market access constraints, distance from production field to markets, obtaining access for long-distance transmission pipelines. The market itself might be too small to support development. Infrastructure is another significant bottleneck sometimes in the monetization of natural gas. Gas volume constraints also sometimes present a roadblock or speed bump in the process of monetizing gas. Government constraints, as I mentioned before, the legal, regulatory, and fiscal framework are important elements in making sure that every party along the value exchange can realize value from the gas that's brought to market. And there's always operational conditions that interject themselves. Due to the nature of the oil reservoir, reinjection, for example, of associated gas is not always a technically feasible option. Safety-driven flaring occurs for several reasons, including process malfunctions, emergency shutdowns, high-pressure conditions. One of the key frameworks that is explained in the document and that is used throughout is the categorization of flaring. Shown on this graphic is the GGFR partnerships definition of gas flaring summarized in the table. As shown, routine flaring, which can be continuous or intermittent, occurs during normal oil production operations when there is insufficient infrastructure, facilities, or geology to re-inject the associated gas, utilize it on site, or send it to a market. The second category, safety flaring, covers all situations where a flare is used to maintain safe operations of the oil and gas production facilities. The third, non-routine flaring, is all other flaring rather than routine or safety flaring, which can be scheduled, planned, or other types of maintenance activities, unscheduled activities, equipment failures, and the like. Distinguishing safety and non-routine flaring from routine flaring is critical in order to reduce overall flaring volumes, as globally a large fraction of the flaring occurs because of economic conditions and choices that are not related to safety-related issues. Regardless of how flaring is regulated, administered, or controlled by government authorities, all flared gas scenarios are covered by the three definitions. There is no fourth definition that addresses government-approved flaring. Instead, determining how flaring operators align with compliance requirements established in local law and regulation is a separate question for the upstream operator to consider when developing their program. Now, I'd like to touch on a few of the market options that exist for bringing associated gas to market. There are a number of alternatives. Starting from the left-hand side is gas reinjection to the reservoir to enhance liquid recovery. This is often the preferred vehicle for using associated gas since it provides additional value added in terms of extra oil production. However, sometimes the geology and the formation is not amenable to reinjection, so other alternatives should be considered. The slide lists in graphic form and in bullets several of the more popular or more common types of options. The first that is shown is compressed natural gas. CNG is used in a transport environment and where markets are fairly close to the field. It is oftentimes a very economic alternative to flaring. Obviously, gas that's produced can also be used by the operator to generate electricity or heat for on-site usage. Sometimes, however, this can be difficult in remote locations, but there are a number of vendors who are coming out with new technologies that can bridge the gap. For large volumes of associated gas, the idea of gas to wire which means installing grid-scale electricity generating facilities, is a very economic and worthwhile option. Typically, gas-to-wire projects, however, though, are capital intensive, and they require close coordination among many partners. They often involve extensive government agency oversight and typically involve many stakeholders. A new theme that's emerging is something called gas-to-power data centers. So here's the case where remote facilities, sometimes too far from a market offtake, can utilize on-site or in-field equipment to generate electricity and co-locate data centers, which can then be used as satellite bridges to do heavy-duty processing. Gas gathering systems, which is this idea of taking the gas and delivering it to customers in its natural gas form, is another option and probably a preferred option. However, there are many roadblocks to installing the necessary infrastructure and getting the government approvals, as well as developing the market for that, where no market currently exists. Another option is gas to liquids or gas to chemicals. This is the conversion of natural gas to either chemicals, fertilizers, building blocks for plastics. A number of technologies exist to take natural gas to those endpoints. In addition, with the current emphasis on clean energy and energy carriers, there's a lot of energy right now around using natural gas via steam methane reforming or autothermal reforming to turn it into hydrogen. Couple that with carbon capture and sequestration to create blue hydrogen, as it's now termed, to help satisfy a need either for transportation or for grid scale type electricity generation. And then finally, a long-standing option is to take large volumes of associated gas and convert them into LNG. This is obviously a highly capital-intensive, very unique solution that only warrants itself in very large fields. However, there are technology providers out there that are making LNG on a micro scale available, where it can be done in field and transported in its liquid form to closer in markets. I want to give a shout out to the GGFR. They have published a lot of documents around technology options on using associated gas, especially those that are focused on small scale solutions. And I would recommend the audience dive into the GGFR website to learn about those. So let's talk a little bit about the constraints and the considerations for flare gas reduction projects. There's many operational and technical considerations that must be weighed during the evaluation of gas utilization options. In addition, there's commercial and logistical issues as well. Market conditions obviously play a key role in the evaluation process. The key technical and economic considerations for flare gas projects are summarized in the top table. We begin with gas volume and forecast. The profile reflects the cumulative effect of natural decline and output for producing wells, balanced by the development plans to maintain or grow production in the field. The projected available volume has a strong influence on the types of gas utilization projects that are likely to be economic, but uncertainty about how production rate from the field will change over time presents a challenge for system and equipment sizing. The figure at the bottom of the slide presents various utilization options that are applicable by project scale in terms of associated gas volume. Gas composition associated from associated gas wells can also vary over time. If the stream is a composite that comes from many sources, there can be a substantial variation in gas composition and impurities as new wells come online or as other wells or production facilities are taken offline for maintenance. The changing composition makes it more challenging to design facilities than those from dry natural gas. Pressure is also a significant technical issue. Steady, elevated, or high pressure is preferred due to the reduced cost required for treatment and compression. For fields where gas pressure is variable, operation of gas gathering systems can be difficult. This is especially true for shale oil developments, where there's often aggressive infield drilling, which creates a string of new high pressure and high volume wells intermittently over the course of the life of the field. This can create pressure and flow surges that enter into a gathering system, which then sometimes either consume the system capacity and crowd out older and lower pressure wells, forcing gas to flaring. Distance to market, covered that before. Obviously, the longer it is, the more difficult it is to arrange pipeline, land access, and the connection points from the source to the market. Getting access to existing infrastructure can also provide to be a challenge. Obviously, there's contractual arrangements, but as well, there's stakeholder issues when large facilities such as electricity generation, gas plants, pipelines, or LNGs plants are involved. Costs and revenue are high on the list of issues that often emerge in considering gas monetization. The concession terms for the lease, the price risk for the products produced, and the size of the capital investment required are among the key drivers for cost considerations. Market demand is also another issue that has to be evaluated carefully. The size of the market will determine how much gas can be used, at what price, and at what return. Contractual and financing options are often issues that have to be considered carefully. Many times, especially for large projects, the scope of the project is beyond the scale of a producer or even a resource owner. So complex arrangements requiring multi-party investment options are often involved. And this adds a degree of difficulty to bringing any gas monetization project from concept to market. So I'd like to turn the table a little bit and talk a little bit about company flaring policies and procedures and the issues that are surrounding those topics. For an individual production operator, addressing gas flaring begins with a commitment to attack the problem and follow through with a disciplined approach of organization, planning, and execution. Many of the folks on this call are familiar with common flaring situations, such as when gas production exceeds existing gas infrastructure, where gas volumes are low, a third-party gas off-taker declares force majeure and can't take gas any longer, or where there's mechanical difficulties. In this section, we'll walk through each of those and talk about the mitigation of gas flaring, and it rests on the identification of project design solutions for new assets and the elimination of existing or legacy assets that can successfully turn the gas from a flare output into a market output. So in the unconventional and shale space, which this has been the most recent development in history of oil development, especially in the United States, where horizontal drilling and hydraulic fracturing have been significant drivers for oil production and associated gas production rates. Significant attention has been placed on the production of substantial volumes of associated gas and the corresponding increase in flaring due to unconventionals. The left side of the slide shows some of the challenges to address flaring. Wells typically have a high initial production and steep decline curve. Consequently, to grow production from a field, or even just to maintain production levels, an operator must drill new wells and complete at a rate beyond that required typically in conventional fields. Growth requires ongoing high-level drilling activities. Flowback for hydraulic fracturing generates a mixed stream of crude oil, completion fluids, produced water, and solids. Solids prevent the flowback stream from being processed through normal production facilities. Instead, the stream is sent through special temporary facilities for a period ranging from many days to weeks to remove the solids and separated crude oil, water, and gas, which is often flared. In tight oil formations, it's not unusual for the gas-to-oil ratio to gradually increase as wells mature, increasing the issue of associated gas production. Another challenge for production operators and midstream entities is to match the equipment design with the high initial production and steep decline profiles for operating areas. Build out of the infrastructure to gather, process, and transport associated gas and related liquids often lags the growth in gas volumes. A major reason cited for this is the disconnect in different planning and development horizons for producers and midstream entities. While it can take only 6 months to bring a well online, gas processing plants have lead times of 18 to 36 months, depending on their complexity, and it can often take years to bring pipelines online, primarily to secure rights-of-way and complete the government permitting processes. Lastly, there may be a structural issue in the tight oil development space, and that is the attraction of short-term investors. Private equity funded exploration and producer companies are designed to be set up and sold once reserves are booked. Such companies have less incentive for investing in gas infrastructure, particularly when gas flaring is an option. So in the face of these challenges, there are some solutions, and the right side of the slide is meant to show those. The first is pre-planning. If there's any message that's carried through the document, it is this. When bringing fields online and when thinking about new developments, the idea of ensuring adequate takeaway infrastructure that is in place before bringing a well online is a key requirement. It means that capacity is viewed as a constraint that is manageable instead of one that is taken as a given. Hand in hand with the pre-planning is securing upfront capacity agreements with midstream and downstream off-takers. In fact, in the state of North Dakota, where associated gas flaring has been an issue for several years, the state had ordered a firm service contractual agreements be set up along with natural gas gathering pipelines to alleviate the probability of well shut-ins and flarings. Such contracts may provide a greater level of certainty to producers and encourage faster development in gathering line infrastructure because economic risk is shared then between the producers and midstream companies. Technology offers a partial solution, and that is through the application of vapor recovery units, where the gas is separated and collected and put into pipes or into other monetization alternatives. And then a couple final things and that is thinking about the resiliency of the operations themselves. Increasing the reliability within the supply chain can mitigate the duration and volume of gas flaring caused by upsets. Actions to grant overtime, expedite parts, move crews around, and obtain temporary equipment are all valuable in reducing the scale and scope of flaring. And then finally, the market is delivering solutions as well. A number of well service providers are offering equipment leasing options to address gas flaring at the wellhead or in the production area using portable skid mount solutions. The ability to scale using modular equipment to follow capacity declines or increases makes these leased equipment options attractive to address the most challenging of flare gas application. When thinking about new fields, the consideration of associated gas capture and monetization should be among the highest priority tasks carried out at the earliest stages of planning. Since market, governmental, and commercial aspects can present hurdles to associated gas projects, and the planning cycle is often longer and more complex than for crude oil production. However, options for gas utilization and newer technologies should still be considered at the outset. A model approach for a company policy to drive pre-planning should consider the following elements. First is to establish a goal that all planned routine flaring of gas, whether continuous or intermittent, is to be avoided even if allowed by government regulations or agency-issued authorizations. The only flaring capacity that would be designed into the system is that which is necessary for emergencies or disposal of gas due to its composition is otherwise unusable. The development plan should consider adequate takeaway capacity for excess flows due to planned outages and maintenance activities. This should be built into the project plan from the start, and include contingent capacity or shared capacity with other operators, especially in multi-operator field developments. This approach would drive holistic decision-making across the entire field over its planned economic life and generate efficiencies in planning, investment, and permitting activities, and increasing shareholder transparency. During the early development stage, adequate consideration should be given to spare capacity for gas handling equipment, especially compressors, to avoid flaring due to equipment reliability issues. Similarly, consideration should be given to expanding the gas project boundary by engaging other producers, consumers, or infrastructure owners. Alternatively, approaches aimed at modifying the economic approach or improving the fiscal incentives to enhance the viability of alternatives can be explored. As the field goes online, a model approach for company policy covering commissioning might include several elements, such as the gas flaring and venting during commissioning should be kept to a minimum and consistent with the safe and efficient operation of any oil and gas related facilities. All gas handling system processes should be constructed, tested, and commissioned from the outset before first oil. And as soon as possible after oil production starts, all gas should be routed through the gas handling system, with emphasis being placed on employing temporary flares during the drilling and completion phase to avoid venting as well. During well testing and early production, flow rates of fluids, pressures, and other characteristics of the underground reservoir are assessed. The volumes of oil, natural gas, and water are measured to characterize the well's performance. Historically, during this phase, produced gas was either vented or sent to a flare. Companies should consider an approach that would include the following elements. Minimize the duration of the well testing operation to limit the amount of gas that needs to be handled. In fact, there's been many case studies where operators have been able to reduce the time frame for performing well tests, in large part due to better test equipment and more sophisticated data analytics tools. If longer-term tests are, however, considered, technology such as mobile on-site CNG or LNG equipment to collect and use the produced gas should be considered. For wells where hydraulic fracturing will be used, consideration should be given to green completion or reduced emission completions, where temporary separators and other portable equipment is used to capture the gas and route it to a sales line. These green completions are an alternate practice that captures the produced gas and that's generated during hydraulic fracturing and flowback. Portable equipment is brought on site to separate the gas from the liquids and solids, and making the gas stream ready for sale or use in other options. You can see the advantages and disadvantages for the reduced emissions completions listed on the slide, as well as a schematic of what that equipment looks like. Turning to legacy flaring, an essential component in a company-wide flare reduction effort is a top-level commitment and a supportive policy across the company. Combined, these align production, engineering, finance, and other teams within a company to focus on reducing flare gas minimization. It's important for that commitment to be articulated and the boundaries and key parameters documented in a policy so that everyone understands and is clear about what the boundaries for the operations are and for what the program will cover. It often helps to establish a clear commitment to reduce or eliminate all routine flaring through adoption of a recognized program like the World Bank Zero Routine Flaring by 2030 initiative. Establishing a process to raise questions and work towards a common understanding of definitions and boundaries to align understanding, eliminate conflicts, and build support for goals is another key ingredient. Considering the zero routine flaring definitions is a great way to start building a company-specific rule book to help document all of these details that arise when engineering teams, operations teams begin to wrestle with the issue of associated gas flaring and its monetization. Goals and metrics drive progress across the company, And these are very useful in helping raise the visibility and provide immediate feedback for those folks who are actually involved in operating facilities. Developing a structured plan to facilitate implementation and focus attention is a terrific way to systematize the process for looking at flare gas opportunities. I mentioned before the document that was put together by GGFR, Ipieca, and OGP in 2011 is a very pragmatic approach to identifying opportunities that can address legacy flaring. The graphic on the slide summarizes the structured 7-step decision-making process to prioritize opportunities and support decision-making to reduce flaring and develop gas utilization projects. It is still a very useful tool to guide operators, and I encourage everyone on the call to look at it. There are worked examples in that document that I think are very enlightening. Another key element is active monitoring of progress. It's essential for people to have feedback as to where the company stands or where the flare gas volumes are being handled. It requires, though, however, an accounting system that the company can rely on to deliver accurate data to the folks that are involved in managing associated gas. And finally, economics. They're always involved in dealing with flare reduction projects, especially those for legacy operations, even when a good technological solution can exist. So consideration of unconventional approaches to financing flare reduction projects can help overcome the typical response, which is that it doesn't meet the internal rate of return, and reduce the amount of capital maybe that must be funded by the company itself. So turning to routine flares, I'd like to talk a little bit about the process that's involved in managing the elimination of associated gas flaring. So we'll talk about assessing local conditions, reviewing gas forecasts, developing a strategy, assessing technologies and economics, and talk a little bit about financing. So any project that's looking to reduce routine flaring must begin with an identification and assessment of the allowable conditions for how that flare reduction plan can fit into the actual on-the-ground reality. In assessing local conditions, a wide net should be cast because constraints include allowable legal flaring activities and conditions on the utilization of natural gas. And these can create opportunities as well as constraints on how gas can be handled. Compliance with local and regional regulations and policies covering environmental protection, safety and risk management, land access are some of the examples. Also, applicable legal structures and commercial conditions covering gas resources and gas infrastructure ownership can significantly impact the choice of flare reduction project activities. Local stakeholders, non-governmental organizations, and public expectations form another important context into which flare reduction activities must fit. Flare reduction projects may also be shaped by government incentives, carbon taxes, and/or goals that call for the utilization of a certain percentage of produced gas in support of local industry or to provide gas to local communities. Creating a thorough understanding of the context for flare reduction in a region will lead to better choices and better prospects for successful execution. The investments made to form or strengthen relationships with key partners and to build understanding of issues will create a climate of shared objectives and drive success. Following the assessment task, it's essential to have a reliable gas forecast. For legacy assets, knowing where to focus the activities of a flare reduction program is key to achieving successful outcomes. Obtaining information on the different gas sources and flare points is essential, including mapping of all flare gas sources and volumes, compiling data on gas composition and pressures, and understanding the volume of gas flaring over time. For most operations, and especially for tight oil fields, understanding drilling plans, decline rates, and GOR data is a must. The amount and quality of data available often change as the resource matures, so this is another factor that should be built into the assessment process. One of the first steps in building a flare gas utilization strategy is to understand what volumes of associated gas are available for monetization. On the page here, there's a graphic on the left-hand side that shows there's multiple levels of uncertainty and variability over time, which make flare gas monetization challenging. This is why producers develop P90, P50, and P10 forecasts. This uncertainty also translates to associated gas flare volumes. Even, for example, at an assumed production level, say P50, there is short-term variability in gas production, and over longer time frames, uncertainty. The figure provides a conceptual production profile for an associated gas based on one possible oil production profile. It shows the segments or tranches of proposed possible gas production volumes over time, ranging from the most certain, which is the V1 segment, to the least certain, the V4 segment. Only the V1 certain, since it's certain and relatively constant over time and over the life of the field, is useful in amortizing the investment of any gas capture and utilization project. The volumes 2 through 4, as volumes 2 through 4 become increasingly uncertain and likely more variable, each tranche becomes more challenging upon which to base a capture and utilization investment project. To achieve zero routine flaring, and given that only production volumes with higher certainties are typically bankable, it's important to develop a commercial marketing finance structures to address and de-risk the specific feedstock supply uncertainties represented by those tranches labeled V2 through V4. The concepts are captured in the table. So moving from top to bottom, as gas volumes become less certain and likely more variable, monetization projects become more challenging to develop and finance. It doesn't mean that they can't be done. It just means more brain power has to be applied to make them happen. Once a concept or a strategy has been fleshed out, there are many other questions that have to be considered. Whether it's own consumption or whether it's taking flare gas to market, a number of factors must be thoroughly evaluated. But for those that involve taking flare gas to market, the list of issues typically are longer and require more thoughtful evaluation, since they impact not only the producer and the resource owner, but typically midstream and final off-takers as well. Listed on this slide are just a few of the questions that are involved, categorized into broad themes. Beginning with the technology, for example, what is the performance characteristics and risks of the technology that are going to be applied? How mature is the technology, and has it been commercially demonstrated? And how does it compare to other existing and near future competing technologies? From an economic perspective, what are the capital costs and estimated values and sensitivities and uncertainties? What are fixed and variable operating and maintenance costs? What are the expected product prices and revenue over the project's lifetime? And what are the hurdle rates and cash flow sensitivities that every player along the value chain is facing? From a financial perspective, what are the most likely methods of financing the project? Is it going to come from internal capital, external debt, equity, or perhaps other multi-party financial sources? And what market conditions are necessary for or sufficient for the technology to be deployed and sustained over the life of the project? Other factors include government involvement and oversight, stakeholder issues, and the value chain risks that can be anticipated as you build out the value chain from the producer all the way to the off-taker. And then structuring the contracts and the financial instruments to take risk out of the process. Summarized on this graphic is a thumbnail of many of these considerations. The economics of flaring versus capture and sales of associated gas can be difficult to assess. So this graphic is meant to synthesize a variety of the options into one simple graphic. the key takeaway from this slide is that any project evaluation should be done in a systemic fashion. The key questions are what technology solution is commercially preferable under a given set of operating scenarios and market conditions. Output from the options analysis should identify and evaluate the main advantages and disadvantages of the projects and the critical factors that influence their success. Typical decision criteria for screening alternatives may include technical feasibility, capital, alternative uses of investment capital within the producer's own sphere of influence, the market demand, natural gas pricing, lease and concession terms. There's a host of issues that need to be considered, and the document itself walks the reader through all of these. The final topic I'd like to cover in this particular section is green or climate change financing opportunities. For large projects where the required investment cannot be funded solely by the producer or the resource owner, the proponents for a project can choose to pursue external financing, typically a loan, to initiate construction. Commercial banks are traditional sorts of project finance. However, another source of funding is green finance, which is focused on funding projects with positive environmental outcomes. And a subsector of that which is known as climate finance. This refers to local, national, or transnational financing that seeks to support mitigation and adaptation actions that will address climate change. It can be sourced from capital markets or government budgets and channeled through various multilateral and bilateral agencies and a multitude of private financial intermediaries. There is much innovation in the area of green finance, and new financial products are being developed all the time to marry the desire to fund climate-focused projects while providing attractive returns for investors. Use of green bonds is one example. Another option for climate-related finance has been the issue of carbon credits. Projects that generate carbon credits are growing in popularity. Many companies have included offsets or credits as a key element of their net zero strategies. And so projects which can generate these credits and can do so in a technologically and verifiable fashion create credits that are very worthwhile to the generator. Talk a little bit now about non-routine flares because it's an issue that does relate to a significant amount of gas flaring. It's a more challenging, though, situation than those where routine or continuous flaring exists. The next few slides describe the section in the flare management guidance document that covers how to manage non-routine flaring to as low as reasonably practical. It begins by making the organization aware of the issue, includes methods to handle unexpected challenges, and covers some very technical issues related to root cause analysis, bad actor identification, and equipment sparing. Oftentimes, the first step in addressing non-routine flaring is recognizing that there is an issue. Non-routine flaring is distinguished from routine flaring by the cause, magnitude, frequency, and duration of those events. It's generally characterized by infrequent occurrence, high emission rates, and short event durations. By its very nature, non-routine operational flaring can be difficult to predict and track in the absence of adequate metering or other monitoring tools. Unexpected process upsets that are outside the normal steady-state plant process and equipment operations are often the source of such unpredictability. The important information associated with non-routine flaring includes the length of time that a piece of equipment is offline, that gas is sent to flare, that utilities are unavailable, and the length of time it takes to fix the problem. Many locations in the oil field are unmanned and only have basic monitoring instrumentation, so flaring can often go undetected for a period of time. However, recent advances in remote sensing by satellites have provided tools to survey large areas and reveal instances of flaring that that before today haven't been seen. The image is an example of one of those satellite overflights. Other organizations are using aerial surveys and fixed and ground monitoring stations to also look for flaring. Once awareness has been raised and a problem has been framed, it's important to have a management process for dealing with non-routine flares. The graphic on this slide was prepared by the Texas Methane and Flaring Coalition, and it, like the prior slide, which showed a stepwise process for addressing legacy and routine flaring, offers a roadmap for how non-routine flaring can be managed from the inception of an idea all the way through to solution generation. The challenges with non-routine flaring exist in the context of becoming aware of the problem, understanding where it occurs, its inherent unpredictability, and the challenges of applying a technological solution to a problem that seems to always be one step ahead of the folks who are charged with chasing it down. One of the most important tools for dealing with non-routine flaring is setting flaring targets. These can be powerful motivators for behavior within an organization. But to be effective, they should be aligned with the company's strategy and reflect the operational environment and competitive landscape and fit within the context of the culture of the company. The specific metrics chosen and the levels to be attained by a certain time must be informed by the intent behind the strategy to drive progress. Program leadership for any target setting program should be led by a senior operations manager position, someone in that position. This person, supported by staff, can provide the necessary focus, sanction targets for individual operating units, and then hold them accountable for performance. And importantly, oversee a waiver process for those extraordinary situations where things just fall outside the norm. Key performance indicators for flaring volumes can either be absolute or rate-based. Absolute targets are used to drive towards a new end state, a zero goal, or a new operating regime. They tend to connote transformation of an organization. Intensity targets or relative targets drive progress in relation to the way things are. They connote gradual evolution, and because each of those targets has a specific purpose, combining multiple types of targets can often yield a more effective outcome than using just one. The document itself provides examples for calculating and setting those targets. A bit about waivers. This is an important component in any program dealing with non-routines just because of the inherent unpredictability and the inability of teams to envision all possible scenarios. So there are a variety of elements that should exist in a structured waiver process. These listed on the slide. But the most important thing is that meeting production targets should never be the driving justification for a waiver. The allowance of non-routine flaring in the face of a public commitment to eliminate such practices could cause a company's reputational profile to erode, possibly to the point where it limits the company's ability to continue to maintain or grow its oil production in a particular region. This slide highlights the idea that oftentimes in chasing non-routine flaring solutions, there's a highly technical component to it, which is this idea of doing a root cause analysis and thorough investigation behind each of the situations that ultimately result in non-routine flare. A bad actor program, which is based on this incident investigation framework, can identify those operational factors or equipment or themes that result in non-routine flaring. Once such a program is set up, it's remarkable in that oftentimes 80% of the issues are identified as coming from 20% of the root cause problems. So the strategy to surface bad actors, again, through root cause analysis, is the application of through the application of tools and techniques to uncover the source of such events, and oftentimes relies on existing investigation and root cause analysis tools that exist within companies today. Targets for in-depth investigation can be identified through queries of maintenance management systems that look at classes of equipment or repair costs and the number of outages by equipment type. The investigation should look for primary and contributing factors by examining many of the areas that are listed on the slide, such as an inherent design, a defect in the material of construction, faulty equipment or control logic, improper operation. The benefit is that many studies have shown the cost of unplanned emergency work is 4 times the cost of planned work. So the more effort is placed in identifying and addressing these root cause problems, the better off the operations are in terms of reliability. And in addition, the longer assets that are on the ground can be extended without major redevelopment. Rotating equipment is a big issue associated with gas handling, and so a sparing strategy for developing either standby spares or the flexibility to bring equipment on line from other parts of the field is a critical piece of any program to deal with non-routine flaring. The document itself provides a little bit more detail and many references to how the structure of that process and the strategy is developed. So the final section that I'd like to cover, because I know I'm getting short on time here. Yep.
Yeah, it's Jim here. If you could speed up a bit, that would be great to allow time for the other presenters. That would be appreciated. Thanks.
Yeah, fine. Wonderful, Jim. This slide gives an overview of the last section of the document, and I know we're going to have a speaker from GGFR talking a little bit later in the session here. So the idea here is that for those folks who are in government or regulatory agencies, there is a step-by-step process that the Flare Management Guideline steps you through to be able to assess your organizational capacity, the institutions that exist to manage associated gas flaring, and the capacity that is needed to build to provide the required policies, regulation, and institutional frameworks to address the program efficiently and effectively. Policies and regulations are obviously key in that process to address associated gas flaring, and linking those policies and regulations with the institutional support structures is the key ingredient of making the program work at the government level and work for the producers and the entities that are along the value chain. We talked through before this idea of tranches of gas, and so if a government entity is involved in helping set up or develop projects, those same considerations need to be thought through in structuring a project and how the producers, the midstream entities, and the off-takers are rewarded for their risk. Project origination means setting up those structures to take a project from concept to fruition or to delivery. Again, there's a host of questions that need to be addressed in thinking through all the details of how that project can be set up. The key takeaway is that there is risk for players along the value chain, and so careful consideration for how to de-risk as much as possible or balance the risk and rewards for the players along the value chain is critical. And the final slide is funding. The document goes into a number of sources of funding, both private equity, owner financed, as well as the multilateral institutions that exist, such as multilateral development banks who coordinate and quarterback the delivery of financing. Shown here on the slide are several recent and different kinds of funding that has come to be known around flare reduction. So you can see it goes from consortium, OGCI, it goes from private equity, the Caruso example, it goes from government partnership, and then multilateral through the IFC. So again, the document itself gives a lot more detail on financing. So a sprint to the end. Thanks, Jim, for the reminder, and thank you all for your attention and consideration.
Thanks, Carl. It just shows just how much great information there is in the flaring management guidance and just how much we have to get through in this particular webinar. So I'll now hand over to Thomas Hurlbacher of Wintershaldea to talk about a case study. And if you can hopefully keep to time, Thomas, that'd be great. And remember to switch your microphone on. So over to you, Thomas.
Thank you, Jim, for the introduction. And I will personally keep it a bit short to allow more discussion actually in our question and answer session. What I will present is a project in Argentina where we collected the associated gas from an extended well testing facility. First, what I wanted to start with is the introduction of our greenhouse gas targets. Wintershaldea has set greenhouse gas targets, 3 actually. One old one, the oldest one, is the zero routine flaring by 2030 as defined in the by the World Bank in its program where we are actually discussing. Then in the year 2020, we defined the net zero target in 2030 to be net zero in own operations, but also partner operations for Scope 1 and Scope 2 greenhouse gas emissions. And last but not least, we have a methane intensity target to reach 0.1% by 2025. We are also member in Ipieca, but also the Oil and Gas Methane Partnership, OGMP2, and the Methane Guided Principles, the MGP. So what do we talk about? We talk about an 8-inch ANSI 600 pipeline with a length of approximately 9.5 kilometers. And an installation of the usual connection to a well pad where there is a compressor located on the well pad and then a tie-in station at the facilities where we are delivering the gas to. In the end, the whole system with a 8-inch diameter is already sized for a facility to handle all the gas, all the associated gas produced in the following steps. And this is an unconventional project, so the steps are defined by the number of wells drilled and brought into production. Here we talk about black oil, that means it's about 45 degrees API, and 140 cubic meters per cubic meters. This is, sorry for the Argentinian units of GOR. We realized the project construction-wise within 11 months. The originally budgeted costs were $10.4 million US, and we reached an investment capex value of about 7.8 in the end. That's where we are. We had some problems during construction, some considerations which we needed to survive, I would say, a framework, international framework, and problems with the COVID-19 pandemic. The whole project was constructed during that phase. And in Argentina, we had the pretty strict COVID restrictions, especially in the year 2020. 21, it got more liberated and it got more possible actually to do construction work in the field. The construction work in the field, was a bit difficult also due to natural problems like a big thunderstorm where we had floodings, but also we had problems due to local strikes where we lost a number of about 3 weeks for social unrest. for us was a new project to organize it with also newly established local governmental agencies. We cooperated with all of them, and especially a new one which treats the surface water was the one which actually gave us a multitude of problems. So every agency was working in its own silo, and we had to deal with all of it. In the end, the first gas which reached our contact delivery point, which is actually a gas oil separation plant and gas treatment plant by Total Energies nearby, was delivered on the 10th of August 2021. And as mentioned before, it was not so easy to get there, but in the end we were luckily successful, which reached in total to a reduction of 12,000 tons of CO2 equivalent per year. This is the as-is status with the number of wells producing. It will be way higher as soon as the actual development is happening in the area of Vaca Muerta, province of Neuquén, actually. And out of these 12,000 tons of CO2 equivalent, we eliminated about 110 tons methane emissions. And most important for us, we reached the zero routine flaring target. Just what I want to mention in that context, the zero routine flaring is one of our major targets, which we try to reach everywhere. But in the end, here, there was also a lot of pressure from the environmental agency of the province of Neuquén, because they grant the flaring permit, and they grant flaring permits only if it is severe reasons, mostly economic reasons for the involved companies. And the tendency is that the duration of such a permit gets smaller and smaller, and they really take a lot of care to utilize the associated gas, which is good, but for us was adding quite some difficulties here due to time pressure and organizational issues. Yeah, safety-wise, we had 3 near misses reported, which is not much, and we are happy that there were no LTIs. About 111,000 man-hours were spent, and a lot of safety observations mentioned and collected. And we are happy that this project came to a positive end. Yeah, also eliminating the flaring. Thank you. That was in brief the summary of the well testing gas capture project by Wintersaldea in Argentina. Thank you.
Thank you very much, Thomas. And we can hand over now to Sarah Alcal of Qatargas to present her case study. So over to you, Sarah, and remember to switch on your microphone. Thank you.
Hi, everyone. So thank you for the introduction. My presentation is about Qatargas's Jetty Boil-Off Gas Recovery Facility. It's the winner of Qatar's Sustainability Award in 2018. So the main objective of the Jetty Boil-Off Gas Facility is to reduce flaring. And it does that by recovering the boil-off gas previously being flared during liquefied natural gas ship loading. This facility recovers the boil-off gas from 6 loading berths operated by Qatargas at Ras Laffan port in Qatar. And the company invested $1 billion in this project. It's 100% environmentally driven, and it also contributes to the 2030 Qatar National Vision, emphasizing environmental protections and sustainability, and it also supports Qatar in its aim to reduce its greenhouse gas emissions. Okay, now I will go into more details on the concept of this facility. So the main product of Qatargas is liquefied natural gas. And through the presentation, I'll be referring to it as LNG. So LNG is natural gas cooled to negative 160 degrees Celsius. Liquefying the gas significantly reduces the volume by 600 times its original volume, making transportation much easier. We transport our LNG to customers by shipping vessels, and during the loading process, around 1% of the LNG is evaporated, and that is due to the difference in temperature between the LNG and the ship tanks. And we refer to this evaporated gas as boil-off gas. And before the construction of this facility, this boiled-off gas was sent to the flare, but now this gas is collected from the ship and transported by stainless steel pipelines to a central compressor area, where the gas is compressed to 47 bar in 3 stages, and then this gas is sent back to the LNG processing facility to be used as fuel. We also have an option to convert it back to LNG, but it's rarely used. So this project was the first of its kind in the region, and naturally we faced some challenges, and we had to come up with technical innovations. So this slide shows a few examples. Our first stage boil-off gas compressors are some of the largest ever built in the world, handling a volume of 163 tons per hour. The reason why we need such huge compressors is because the gas expands as it travels to the central compression area, and that is due to the increase in temperature and drop in pressure. And one of the major challenges that we faced during the design was to find an inlet guide vane that can handle different inlet volumes at a wide range of temperatures, ranging from negative 140 to ambient temperature. This guide vane had to be specially designed for this facility. Another challenge that was faced during the design was to design a check valve that could work with the very low pressure drop allowed between the ship and the compressor. There were multiple studies carried out, which resulted in designing a lightweight titanium flap that uses aerodynamics to reduce the drag and increase the lift. Okay, so now I'll talk about the benefits of the jetty boil-off gas facility. It recovers more than 90% of the boil-off gas that was previously flared. That is equivalent to 600,000 tons per year that would have otherwise been flared during ship loading, which is enough gas to generate 750 megawatts of energy, and that can power around 300,000 homes. This also helped us reduce our greenhouse gas emissions by around 1.6 million tons of CO2 per year. And to help you visualize this reduction, we would need 80,000 hectares of rainforests consisting of 40 million trees to reduce a similar amount of CO2. Okay, and this brings us to the end of the presentation. It was pretty short. So thank you for your time and attention.
Thank you, Sarah. Short, but very illuminating. So thank you for that case study, and thank you also, Thomas, for the prior case study. I'm going to hand over now to Martin of the GGFR. Apologies, Martin, for drawing the short straw. We've had a lot to fit in, and we were, as always, a little bit on the ambitious side. So, Martin, if I can hand over to you to talk about the regulatory study of the World Bank GGFR partnership, and if you can switch on your microphone and take it away. Thank you.
Okay. As mentioned, my name is Martin Oswald, and I take care of the regulatory agenda within the GGFR program in the World Bank. Before getting into details on the key findings of our global regulatory review on flaring and venting, I would like to quickly thank the other presenters, because with their practical insights from projects and their
Martin, it's Jim here. I think we've lost your image is freezing. If you could refresh, maybe that would help.
America, US. I understand.
Hey, Martin, we got you back for a second and you've gone again.
The message once I'm back on.
Martin, it's Jim again. You're drifting in and out. Apologies, everyone on the line. Martin is located in Dakar in Senegal, and the signal, the broadband signal, could be weak and intermittent there. I think we certainly lost visuals. Maybe Martin, if you switch your camera off, that might help with the broadband width, and just use the audio. No, Martin, we're not hearing you. Martin, I don't know if you're talking, but you're not coming through. Okay, I think we've lost Martin for the moment. He's going to try and dial back in. But meanwhile, while Martin's reconnecting, if I could just mention in the, we'll try and take some Q&As. But the first thing to say while Martin's reconnecting is just to let you know that a recording of the webinar will be available in the next couple of days, and it can be accessed on the same link as the live webinar. And in the resources box, you will find today's presentations, including Martin's if we can't get him back, and they can all be downloaded. And also the joint flare management guidance itself, and accompanied by a short summary, and the short summary document is in English, Arabic, Russian, and Spanish, and all that material is now available for you to read and download. And if you click on the logos in the top left of the console of your screen, it should take you to the documents on the Ipieca website, and the information will be there already, and we will follow up to those folk who registered with a link to the actual material on the website. I'm not seeing that we've got Martin back, so maybe if I can just pick up one question, and I think in the interest of time it will be what I would call a humdinger of a question. That's come up and said, what is your view on the advisability of using flare gas to power Bitcoin mining? And I think I'll hand that over to you, Carl, seeing as you did mention the opportunity for these types of mini projects where you can take the associated gas and use it to make electricity for data sources. So whilst we're getting Martin back, perhaps, Carl, if you'd want to start with an answer about Bitcoin mining, not a question I ever anticipated getting.
Well, thanks, Jim. I guess I lost a toss-up, right? So that's why I got stuck with the question. But I do wish I had some Bitcoin. But as to the particular question that you raised, there is a lot of work in the U.S. that I have seen in the press about using coal-fired plants to power data centers and especially Bitcoin mining operations. So the option to use associated gas seems like a much more environmentally friendly option to do that work, and I think it makes a lot of sense to proceed along that path. Obviously, there's lots of issues with respect to arranging stakeholder input on that, because I know that's one of the major issues that has arisen around the coal-fired options to do Bitcoin mining.
Thank you, Carl.
Yep.
We are still trying to get Martin back on to the call. Not successfully so far, and I'm conscious of the fact that we've got to our time contract. And as you said, all of the slides are on the resources link on your screen, so you will have access to Martin's slides. Maybe we can pick up one or two more questions if people will indulge us to see if we can get Thomas back. Again, another question maybe for you.
Can you hear me?
All right. Yes, if you switch your camera off, Carl, then we...
It is.
Have we got you back, Martin?
Yes, can you hear me? Yeah.
Yes, we can. Thank you.
Okay,
sorry for all the difficulties. Go ahead.
Okay, my
Martin.
apologies. My apologies. I'm not sure where you lost me, just very briefly. What I'll try to do in my presentation is to put the good practical and project-based information that my fellow presenters have presented to you earlier into a regulatory framework and come up with recommendations based on our findings from our global regulatory review and how good regulation could be implemented, but also how new regulation or existing regulation could be improved. So as mentioned before, and you might have not gotten that because of the connectivity issues, we've looked at 21 oil-producing countries, really from all over the world. I won't go into details for reasons of time, but we really covered everything: North America, Africa, Middle East, North Sea, Russia, Central Asia, and Southeast Asia. So we tried to be as complete as possible and accessing all the available information. And on this basis, we came up with a two-tiered study starting, and the slide shows it here on the lower half, starting with country case studies, where we looked at everything from obviously the legal and regulatory aspects to enforcement and monitoring, enabling frameworks, as well as, of course, the volumetric data from a historic perspective to show what effect those regulations had. And we then moved these per country insights into a separate report, a comparative review, where we show which lessons can be learned, which recipes, if you will, from the individual countries did prove to be effective, and what recommendations can we give on that basis. And that's how we came up with those two reports that soon will be published. Talking about April, we're done with our work, but we're now in the design phase, and we're also developing an online tool, which I will mention a little bit later. And obviously, we will keep you informed when this will happen. Now, what are the key themes that we looked at? You can see them here in the blue boxes. Starting off with our policies and targets, a key element in there is, of course, the NDCs, the nationally determined contributions, and we looked to what extent oil and gas flaring and venting was included there. Then looked a level deeper into the legal and regulatory framework, moved on to the government's part, so enforcement and monitoring, looking also into the licensing process that was already mentioned before. Should flaring and venting be part of the development plan approval for a greenfield process? Then moving on, also measuring and reporting, obviously a key issue and very closely linked to that, the fines, penalties, and other sorts of sanctions that you have at your availability if you flare and vent. And then we also looked at the enabling framework. So how does the wider industry context help you or prevent good flaring solutions from happening, looking at connectivity between upstream, midstream, and downstream, for example? Were available, and that's what we try to express with those gray boxes on the right-hand side, we also looked into how effective enforcement is and how well those regulations that we looked at are being implemented. Moving on, and before coming to the really content-heavy part of my presentation, which is what were our findings and what are our recommendations, here is a brief theoretical overview of the regulatory approaches that we've managed to distill in the course of our research. Again, starting at the lower half of my slide, you see this blue chevron. We have categorized the approaches in a prescriptive part that looks at standards and regulations, so it's very much input focused. And then moving on to the right side, there's also a performance-based approach that gives a lot of leniency to the operator to achieve targets, but it's the outcome on which the regulation focuses. Going a bit more into detail, what are the approaches on the prescriptive side? There are, of course, permits. They have been mentioned today. If you want to flare and you fulfill the requirements, you can apply for, in many instances, for a flaring or venting permit with the government, and provided those criteria are being fulfilled, such a permit might be granted to you as the operator. The other prescriptive element is, of course, around penalties, and I should put that as wide as possible. This could be fees, payments, taxes even, as well as other sanctions. And the idea behind here is if you exceed a certain threshold that has been given to you by the government, you will need to pay a penalty. And there are also jurisdictions where payments are required no matter how much you flare. They're just required for all the gas that you flare throughout the life cycle of a field. It really depends on the jurisdiction. Now, moving on to the right, to the performance-based approaches, there is an incentive approach. What I mean with that is you try to motivate the operator to do as much as possible to reduce flaring. And one good incentive could, for example, be preferential access for associated gas, which would otherwise be flared, to the national pipeline system. That could be a good incentive, and it actually does exist in some of the countries. And then the last approach that we've identified is the market-based one. Most prominent, of course, cap-and-trade systems where emission permits can be purchased, but there are also flare gas-specific auctions that can be used. Now, before moving on, I should also say that those four approaches normally are not being applied in isolation. Very often they are being combined. And one thing to watch out for in this context is that the forces that you unleash, they should work in the same direction and should not balance each other out. To give you a practical example, what I mean with that is, if you want to motivate operators or the industry to reduce flaring, you could give them this incentive that I mentioned before, whereby associated gas gets preferential access to the pipeline system. And if you want to give it a further push, you could say all gas that's being flared is subject to a penalty. So this is then a double motivation, if you will, for an operator to feed the gas into the pipeline system, because like this, the operator can generate additional revenues. And at the same time, of course, he saves penalty fees, which otherwise he would need to pay. So it's kind of a double motivation. And what I try to say with this example is, as mentioned before, the forces that you enable should work in the same direction in order for the overall outcome to be what you desire. Now, with all this in mind, let's move straight into the key observations and recommendations that we have derived in the course of working on these 21 countries and 28 country case studies that I mentioned before. So the next 4 slides, they're structured the exact same way. On the left-hand side, you see observations, then you see the topic that we're covering, and then on the right-hand side, you see our recommendation. Now, starting with policies and targets, what we observed is that many countries have set overall emission targets in their climate change commitments, most notably their NDCs, but very few have set flaring and venting reduction targets and regulations to achieve them. And what we recommend in this context is that policies and targets need to be developed that really specify the role that gas flaring and venting reductions could play to achieve these overall climate change targets. You will see once our study comes out that we looked at the NDCs of all the 21 countries that we covered, and we did look if flaring and venting were mentioned as instruments to achieve their NDCs. And so this you will find in our study. Talking about legal and regulatory framework, we did notice that outright bans on all flaring and venting from a legal or regulatory perspective in the primary legislation are largely ineffective because they're impossible to enforce. The first presenter mentioned that there are situations such as safety flaring, emergency flaring. They just they're a necessary part of the industry, as undesirable as they are in terms of outcome. And of course, by saying all flaring is banned, this would not be reflective of reality. So with this in mind, what our recommendation is that the treatment of associated gas must be explicitly addressed in the primary / overarching legislation to outline the fundamental principles to be detailed in the regulation. And then the secondary legislation, which is more detailed, should empower regulators to monitor and enforce reduction of flared and venting volumes through tools such as standards and guidelines, record-keeping requirements, reporting, and of course, regular site inspections. Moving on to governance and enforcement, and those 2 points, point 3 and 4, they are intertwined. What we did observe is that regulators are often poorly resourced, lack adequate skills, and the regulatory and operational processes lack definition and do not empower the agency. So a clear definition of roles and responsibilities between the various regulatory agencies are important to avoid an overlap and to avoid confusion on the side of the operator. And of course, it should be ensured that the regulatory agency is adequately resourced. That leads me to the enforcement part. In many instances, enforcement capabilities are insufficient to achieve the regulatory targets. And very often, on top of it, there is a certain proximity between the regulator and the national oil company, the NOC, and that can lead to a selective behavior regarding which companies to target with sanctions. We therefore recommend that whenever regulation is being passed, it should be done so in close consultation with the enforcement authorities to make sure that the targets that one wants to achieve are actually achievable, and where necessary, i.e. where not even the minimum targets can be realistically achieved, capacity assessment in conjunction with capacity building should be carried out to bridge this gap. And while complete independence of regulators is of course preferred, at least efforts should be made to achieve independence between the regulator and the national oil company to the extent possible. What I mean with to the extent possible, very often the regulator does rely on the competence of the national oil company because, of course, they are the technical specialists. So there is a natural proximity, but it should be tried to still keep an objective distance between the two in order to ensure an even playing field in the market. Now to the licensing and approval process, and also this was mentioned extensively before, designing greenfield development plans for zero routine flaring is not yet a common requirement, as natural as it sounds. So we, of course, recommend that associated gas utilization should be a mandatory element of every greenfield development, and those plans should be an indispensable condition for the approval process. Coming to the economic evaluation, which also has been mentioned before, just as a quick intro, why is that important? Because very often when somebody applies for a flaring permit, these permits often are linked to the operator proving that a commercialization project for the associated gas is not economic. And if that can be proven, then these permits are typically granted. Now, there are two ways to run these economic evaluations. One is the incremental approach, which allows the operator to flare or vent if they can demonstrate that the cost of utilizing the gas exceed the investment cost on an isolated basis, meaning that you look at the commercialization project for the associated gas as if it was a standalone project. And then if your revenues are lower than your capex and your opex, then your cost, then typically you can prove that it's not economic on an incremental basis, and like this you secure the permit. However, there is an alternative approach, which is the integrated approach, which considers flaring and venting a negative externality and includes the costs of assessing the viability of the entire field development. What I'm trying to say with this is that rather than looking at the associated gas project and the oil project in isolation, the integrated approach takes the free cash flows that both produce, and if those combined cash flows are positive, then you have a profitable project that is ready to go away, and as a side effect, your flaring prevention is being taken care of. Our conclusion on this basis is that the integrated approach, of course, tends to reduce gas flaring and venting more than the incremental approach, and ways to capture those negative externalities could be a carbon tax, flare penalties, royalty payments on the associated gas, even if it's being flared. And that, of course, would provide a very powerful financial incentive for companies to invest. And in order to make sure that we have this even playing field, the methodology for economic evaluation should be unified across the industry, meaning that operators cannot pick and choose between an incremental and an integrated approach, but that ideally the integrated approach should be the required tool on the basis of which flare gas projects can then be compared from one project to the other. Measuring is, of course, a key element because enforcement obviously relies heavily on non-contestable data. And what we noticed is that regulators prefer readings of flared and vented gas volumes from calibrated meter installations. And that, of course, can pose a problem because flare gas volumes tend to be small, tend to be volatile, which makes them already a very commercially difficult resource, so to speak. And if you then impose a calibrated meter installation, for example, a fiscal meter, that can be very onerous in terms of cost because a fiscal meter is very pricey compared to a regular meter, or even a mathematical method can easily cost you $1 million. More often than not, a fiscal metering system, if it's sophisticated, could well range in the $2 to $3 million. And as associated gas volumes are typically small and volatile in nature, a pragmatic fit-for-purpose measuring solution, or at least having the option for that, can help to not provide financial disincentives by being too onerous with regards to what sort of meter is required. So, for example, if you have a very small associated gas volume, doing a mathematical calculation on the basis of an oil-to-gas ratio might be the way to go, because then at least you're not burdening the project with a very expensive fiscal metering capex cost. Measuring of results, of course, is tightly linked to fines, penalties, and sanctions. And in our observation, they are often ineffective, either because they're too low to create an effective threat scenario, or because they rely on ineffective monitoring reporting systems and can therefore be easily contested or protracted. So one of the most successful cases of flaring and venting reduction were achieved through a bundle of multiple measures, where you combine monetary payments for flaring, like the before mentioned fines and royalties, with emission fees, and, for example, even an emission trading scheme. So there are countries that combine all those. And this is really one of the key findings of our study, that it's a bundle of measures that is important, because for once it creates this a very effective financial threat scenario. And secondly, it allows the government to apply a very calibrated approach that can be fine-tuned as the situation evolves. And that has proven to be very effective. And this brings me to the last point, which is another very important element that I want to mention, and which has also been already mentioned in parts before, and that is the enabling framework. So very often, an insufficient integration across upstream, midstream, and downstream disincentivizes operators from monitoring their associated gas. And downstream monopolies, low domestic gas prices, a lack of payment discipline on the part of the purchaser, or a lack of connecting infrastructure lie at the heart of the issue. To put a practical example here, if you have an oil field with associated gas production 100 kilometers offshore, and you're willing and able to evacuate the gas, you will only be able to secure an FID approval from your headquarter if at the end of this 100-kilometer pipeline on shore, which will probably set you back by a couple of $100 million, if at the end there is a power plant that is willing and ready to accept your gas and is also able to and has a track record of paying in time and a sufficient amount. If you can't secure that, in other words, if you cannot de-risk the value chain, then most likely you will not get approval for your pipeline investment, and you will rather pay the fine, because after all, it will be cheaper than having sitting on a stranded cost for the pipeline. Now, our recommendation on that basis is that gas price reforms can be powerful enablers for producers to consider monetization options rather than flaring and venting. And key elements to consider here in this context are the right for oil producers to monetize gas, open and non-discriminatory access to infrastructure or customers, market-based energy pricing, and of course, payment discipline on the side of the purchaser. This brings me to the end of the content-heavy part, as I called it before, of my presentation. Here, a very brief outlook on when you will have access to all this information. As mentioned, we worked for a good year and a half on the content. We are now in early 2022 in the phase where we are editing and designing the results. And we're also working on an online tool, and just about April, we should be ready to go public, and will, of course, notify you. And we are particularly proud of the online tool, because what it allows you is to access the information that you will find in our 2 reports with combined 300 pages in a very selective manner. So, for example, if you want to know what are the sanctions in place for flaring in Argentina, and you want to compare that to those in Kazakhstan, you'll be able, with a few clicks, to compare the two and to really look at information that you're actually really interested in. But having said that, of course, if you so desire, you will also be able to access the 2 reports with the 300 pages that I've just mentioned. That brings me to the end of my presentation. I would also like to mention that one of the, let's call them, positive externalities that we gained from these very detailed insights and this position that we built as a source of knowledge on flaring and venting regulation, this was also recognized outside the sphere of flaring and venting, more specifically with regards to methane emissions. And as you know, in the context of COP26, the methane pledge was announced, and shortly afterwards, both the US and the European Commission announced that they were working on methane regulation. And for example, the European Commission had invited GGFR in their consultation process to work on a methane strategy and the subsequent methane regulation. And we're very proud of that. And going beyond that, also the ASEAN country methane roundtable invited us because they're working on something similar. So there's some good recognition that this knowledge that we've built here for flaring and venting will be, to some part at least, applicable also outside. And with that, I really conclude my presentation. Thank you very much for your attention, and I'm happy to take questions later.
Thank you, Martin. That's fascinating, and I think we're really looking forward to when the report and the toolkit is published in the spring. And I think from looking through your slides and listening to your excellent presentation, it seems that there is a complementarity between the joint flaring management guidance and the work that you've just presented on behalf of the GGFR. So that's excellent. I am conscious of the fact that, as always, we've bust our time contract. We said we would finish at 3 o'clock UK time, and it's now well past that. And the software platform that we're using does automatically kick us out in a couple of minutes. So rather than get kicked out mid-sentence, I'd just like to kind of reiterate a couple of things, if we may. that the recording of the webinar will be available in the next couple of days to those who've registered. And it's on the same link as the live webinar. And on the screen you see in front of us, in the resources box, you will find all of today's presentations, which you can download they're in PDF format. And the joint flare management guidance with these summaries in English, Arabic, Russian, and Spanish. You can get access to those by clicking in the console on the top left corner on the logos of Ipieca-IOGP and the GGFR partnership. So if you click on that, then you will be taken to the website where this information is all held. So I think it remains for me to say, because we've gone way over our contract, that it's been a superb exposition of what's going on in terms of reducing flaring. I'd like to thank all of our presenters today for getting through this wealth of important material, and also to you folks for staying on the line and listening to the presentations. And as I said, you can download them. You have access by clicking on the link on the logos to all of the flare management guidance material. So you'll be very well briefed. And we hope that this launch webinar will have helped you get a much better understanding of how the oil and gas sector and with partners such as the GGFR and regulatory authorities will be working to reduce flaring, to get more firmly on the path to zero routine flaring by 2030, and to improving operational emissions from the oil and gas sector in line with the Paris Agreement. So thank you all for staying on the line. Thanks again to the presenters. And at this point, we will close the webinar. So thank you all, and have a great rest of the day and rest of the week. So